Polysaccharides can be joined to each other by a condensation reaction. So you can take two monosaccharides, remove water, and then they're connected, and we call this a disaccharide. And the bond where the water was removed is called the glycosidic linkage. So here's a disaccharide, maltose. Maltose is made of two glucose molecules condensed together. You have an alpha glucose and a beta glucose. See, that one's beta up and this one's alpha down. And we're going to remove the water. There's a condensation reaction giving maltose. Maltose is a sugar that's found, let's say, in beer, and you can see that it has a lot of glucose in it. Maltose is one of those things that is considered to have a very high glycemic index, causing a large rise in your blood sugar. And it's why? Because it's just two glucose molecules and they separate very quickly. To describe this linkage, the glycosidic linkage shown here, what we do is we look at the sugar on the left and we see that it's alpha. So we call it an alpha linkage, and then we number what carbons attach it. Because this is the number 1 carbon, 2, 3, 4, 5, 6. And then this is the number 4 carbon right here, 1, 2, 3, 4. We call this an alpha 1,4 linkage. This is lactose, the sugar that is found in milk. It's made from galactose combined with glucose. So this is beta galactose and this is beta glucose. When you condense them together, you get a beta 1,4 linkage. And so this is called beta lactose oftentimes. Sucrose, which is table sugar, is made of glucose connected to fructose. Glucose we've been looking at, but fructose, the first time we've seen the ring closed form of it, this was an aldehyde right here. And so that's how I'm able to recognize it as fructose. And of course, we look at the anomeric carbon right here, and we see that it's up. So the alpha carbon with the 2 carbon hydroxyl are what are going to condense. So this is actually an alpha 1 beta 2 linkage. Alpha beta 1,2 linkage. Polysaccharides are many sugars attached in a chain. So if one of these little green balls is a glucose, then this is what part of a polysaccharide looks like. So when we're looking at a polysaccharide, we just know that it's glucose all chained together. And these are used for energy storage, and some of them are used for cell wall structures. They're very long chains, and some of them branch like this. Even though they have many hydrophilic groups, they don't dissolve, but they suspend. They form colloids and suspensions. Starch and glycogen will form a colloid, but cellulose doesn't even dissolve up in a suspension, and it's because of its three-dimensional structure. But the key thing is that the polysaccharides are starches, glycogen, and cellulose. All of the plain polysaccharides have the same monomer, glucose. So starch is many, many, many glucose all attached to each other in a big long chain. Amylose is just like amylopectin is just like amylose, but it has branches on the big long chain. And then glycogen is very similar to amylopectin. Starch you get from plants. Glycogen is what's called animal starch, and it's stored and made in your liver. Then we have cellulose, which comes from plants, and it's also made of glucose. Cellulose is what we call the fiber in foods. So let's see how amylose is put together. Here's a glucose, and here's a glucose. They're all alpha. See, the hydroxy is down. We're going to make a 1,4 linkage. Here's the number 1 hydroxyl group. Here's the number 4 hydroxyl group. We're going to remove water, but we're going to do many, 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 many of them. In fact, you're going to have thousands of these all attached to each other. And so what is it I want you to get that amylose is? That it is a 1,4 alpha linkage, and it's made of glucose. Amylopectin looks just like amylose, except it has branches. Those branches are attached by a 1,6 linkage. 1 here, 6 here. And it also is alpha. Notice the hydroxyl is down. There's an amylopectin, that's a plant starch. There are branches, but there's not very many of them, and they're real long. In glycogen, it looks just the same as amylopectin. Alpha 1,4 linkages in the long chain, and then alpha 1,6 to attach a chain. You have branches just like amylopectin, but what you have is lots and lots and lots of little short ones. So amylopectin looks something like this, and glycogen kind of looks like a hairy worm. So when you get starch, like in a potato or in bread or rice, what is it? It's glucose, and it's in the form of either amylose, which is less common, or amylopectin. It's a mixture of those things. When we eat starch, so when we eat potatoes, bread, rice, pasta, our digestive system quickly breaks down starch into glucose. So when you eat those foods, it's like eating tablespoons of glucose. Cellulose is a polymer of glucose also, but in cellulose, look at the carbon here. It's a 1,4 linkage, but notice it's up. So it's a beta 1,4 linkage. And this is the whole reason that cellulose is not digested. Cellulose passes through our bodies as fiber, which is an essential nutrient because your digestive system does not work properly without the fiber. But we don't have any enzymes that will grab a hold of that beta linkage and break it. The only linkages we can break are the alpha linkages. Now, there are some animals that have bacteria in their stomach that allow them to break down this beta linkage. So ruminating animals like cows and goats and termites all have these bacteria that are able to break down the beta linkages. And so when they eat cellulose, they can break it down to sugar, and so they get more nutrients out of something like grass or wood than you or I would be able to get. Now, we do need to eat cellulose even though we can't break it down, because if you don't have cellulose, your digestive system quits moving things through, or it slows down quite a bit. Not only that, cellulose and other plant substances are what allow microbes, the good ones, to grow properly in your gut. And so if you have a limited amount of cellulose intake, you have a very low good microbe culture in your intestines, and it moves very slowly through your system.